This is section 1.9 of Honors Algebra 2, problem solving with equations. And before we get started, I want to remind you that in these videos, when you take your notes, you must write down every problem and everything that I write on the screen. So this section is on basically word problems that lead to equations that we can solve. So the bulk of the work is writing down the correct equation, and then we know how to solve it from there. So it's best if we just look at a few examples, and we're going to look at 3 examples in this video. So example number 1. Tickets to a concert are $19 for seats near the front and $14 for seats near the back. There were 525 more back seats sold than front seats, and sales for all tickets totaled $31,700. How many of each kind of ticket were sold? The first step, whenever we have a word problem, is going to be to define our variables. So we're going to say let x, and we could call our variable whatever we want, but x is what we generally call it. Let x be the number of front seats sold. So the number of front seat tickets sold. Since we're told that there were 525 more back seats than front seats, if we take x, which is the number of front seats, and we add 525 to it, we should get the number of back seats. So x plus 525 must be the number of back seat tickets sold. So this was our first step in solving our word problem, is to define the variables. Or maybe just one variable. Sometimes we'll have more than one. Define the variable or variables. Once we do that, we want to move on to the next step, which is going to be to organize our information. Sometimes that might be in the form of a picture or a diagram. Here it's going to be in the form of a table. So I've made a table where I've got front and back as my rows, and then price, number, and sales as my columns. And I've noted that price times the number of tickets should equal the total sales. If each ticket costs $10, or in this case $19 or $14, then if I multiply the number of tickets by that amount, I'll get how much money I made on each ticket, how much money I'm bringing in on each ticket. So what is the price of each ticket in the front? $19. What's the price of each ticket in the back? $14. How many front ticket seats did we sell? X. And how many back seat tickets did we sell? X plus 525. We don't know either one of those. That's what we're solving for, so that's why it's x, and then x plus 525. So the total sales for the front seats is 19x, 19 times x, and for the back seats it's going to be 14 times x plus 525. But I have to put the x plus 525 in parentheses, because I need to add those together and then multiply by 14. That means my total sales overall, which we knew was $31,700, must be the sum of the front seat and the back seats, right? So I can write that out as an equation. If I add up how much money I'm bringing in on the front seats, 19x, and add that to how much money I'm making on the back seats, 14 times x plus 525, that has to be the total amount of money that we ended up with, $31,700. So I can get that very easily from my table. So that's what the table is useful for. Organize the information in a way that I can discover a relationship between it that will lead to an equation. Now that I have the equation, step number 3 is to solve it. Solve the equation. Okay? Well, I know how to solve this. I'm going to distribute the 14. And 14 times 525 is 7,350. $19x plus 14x gives me 33x. Subtract 7,350 from both sides means that 33x equals 24,420. And then I divide both sides by 33. So x equals 740. My fourth step is to answer the question. And check my answer. So what do I mean by answer the question? Well, if I go back and look up at the question, it says, how many of each kind of ticket were sold? So I need to explicitly state that there were 740 front tickets sold, and how many back tickets? Well, 740 plus 525, which is 1,265 back tickets sold. 740 front tickets, 1,265 back tickets. Now how can I check my answer? Well, I know that the total sales needs to be 19 times 740 plus 14 times 5. So if I take my calculator and I try 19 times 740, I get 14,060. If I take 14 times 1,265 and then add 14,060 to that, I get 31,770, which is exactly what it was supposed to be. So I can always check my answer, make sure I did the problem correctly. Let's move on to example number 2. Each of the base angles of an isosceles triangle has a measure that is 30 degrees less than the measure of the vertex angle. Find the measure of each angle. Geometry. So you have to remember some stuff from last year. An isosceles triangle might look like that, where you've got two sides that are equal. The vertex angle is the angle between those two sides, and then the base angles of an isosceles triangle are equal, so that's those two angles up there. And according to the problem, the base angles of this particular isosceles triangle each have a measure 30 degrees less than the measure of the vertex angle. We need to find the measure of each angle. So step 1 is define my variables. So let's define x. Say let x equal the measure of the vertex angle. Why the vertex angle? Because I know the other angles in terms of the vertex angle. So that means what is going to be the measure of the other angles? Well, they're each 30 degrees less, so x minus 30 is the measure of each base angle. I could have let x be the measure of the base angle, then what would be the measure of the vertex angle? X plus 30. So either way is fine, you just have to make a decision and then follow through with that decision. So step 2, let's organize our information. Well, on my diagram here, I've got that this angle is x minus 30. This angle is also x minus 30. What do I know about the three angles of a triangle? Right. Very good. They add up to 180. So we've got x plus x minus 30 plus another x minus 30 has to equal 180. There's my equation. Step 3 is to solve that equation. So I can do that. X plus x plus x is 3x. Negative 30 plus negative 30 is negative 60. It equals 180. I add 60 to both sides. So 3x equals 240. Divide both sides by 3. And x equals 240 divided by 3, which is 80 degrees. Step 4, answer the question and check my answer. So if I need to know the measure of each angle, then the vertex angle is 80 degrees, and each base angle is 80 minus 30, which is 50. So let's check our answer. Make sure that 50 plus 80, the sum of the three measures of the angles, is exactly 180, and really easily we can see it is. Check. So the vertex angle is 80 degrees, each base angle is 50 degrees. Example number 3. At noon, a cargo plane leaves the airport and heads east at 180 miles per hour. Its destination is 500 miles away. At 1 p.m., so 1 hour later, a jet leaves the same airport, heading the same direction, but way faster, at 450 miles per hour. At what time will the jet overtake the cargo plane? It's flying much faster. It's going to catch up and get ahead. So at what time is that going to happen? Okay, so step 1, let's define our variables. We're interested in time. Often in problems involving time, we'll use t as our variable. So that's what we'll do here. Let t equal the number of hours. When you're defining your variable, you should always indicate your units. The number of hours after the time the cargo plane leaves, or in this case, we know that time is noon. After noon, when the jet overtakes the cargo plane. That's what we're trying to find, so that's what we call our variable. So step 2, let's organize our information. And we can make a really quick table that will help us to do that. So we keep track of the cargo plane and the jet. A really useful relationship that hopefully we remember from Algebra 1 is that distance equals rate times time. I'm writing that backwards here and saying rate times time equals distance. Problems like this generally amount to an application of exactly that relationship. Distance equals rate times time. So, what do we know? Let's fill it in the chart. We know the cargo plane travels at what rate? 180 miles per hour. The jet travels at what rate? 450 miles per hour. For the cargo plane, at what time, how much time is it traveling until the jet overtakes it? Well, since the cargo plane, and t is the amount of time since noon, it's traveling for exactly t hours once the jet overtakes it, meets it. The jet leaves 1 hour earlier, or 1 hour later, I mean. So once they meet, it will have traveled 1 hour less than the cargo plane. So it's going to be t minus 1 hours. So our rate is in miles per hour. Our time is in hours. So our distance must be in miles. Okay, if distance equals rate times time, then the distance the cargo plane is traveling once they meet is exactly 180 t. And the jet is 450 times t minus 1. That's its distance. Okay, so I've got the whole table filled in. What equation does that give me? Well, when the planes meet, what's true about them? Their times are not the same, but their distances that they've traveled are. They left from the same airport, and when they meet, they are at the same place. So their distances must be the same at the time that they meet. So I can write this equation. 180 t equals 450 times t minus 1. Because when they meet, they will have each traveled the same distance. Okay, step 3, solve the equation. So 180 t equals, if I distribute the 450, I've got 450 t minus 450. If I bring the t's to the same side, and maybe put the 450 on the left side, then I've got 450 equals 270 t. Divide both sides by 270, so t equals 1 2/3 or 5/3 of an hour, afternoon. So about we can say 1 2/3 hours, 1 hour and 2/3 of an hour. What's a third of an hour? 20 minutes. So 2/3 of an hour is 40 minutes. So 1 hour, 40 minutes. So that is really me answering the question, making sure I express it with the right units. 1 hour and 40 minutes later. Here are your immediate practice problems. And you should complete these at the end of your notes on the same page or the next page if you're at the bottom of the page. Complete all 4 steps of the problem-solving process on this problem. And for this video only, you do not need to write the problem because it's a word problem and I know you're lazy. Adults' tickets for the museum cost $1.50 more than children's tickets. One day, 200 adults' tickets and 160 children's tickets were sold. The income for the adults' tickets was $30 less than twice the income from the children's tickets. How much does each type of ticket cost? So, complete all 4 steps for that problem. If you have any trouble with it, email me or see me in the morning. And that is the end of section 1.9.